Since the dawn of time, humans have gazed up at the stars and pondered the vastness of the universe. But what if we told you that the mystery of what lies beyond the edge of the universe has finally been uncovered? The James Webb Space Telescope has unveiled a discovery that is shaking the foundations of astrophysics and leaving scientists astounded. It's a breakthrough so revolutionary that it could alter our entire understanding of the cosmos as we know it. So, what exactly did this cutting-edge telescope find at the edge of the universe? Buckle up and get ready for an out-of-this-world adventure as we delve into this groundbreaking discovery and its implications for the future of science. Imagine if you had a time machine that could take you back in time to witness the birth of the universe. Well, the James Webb Space Telescope is just that, allowing us to peer billions of years into the past and take a closer look at the universe's outermost edges like never before. With its cutting-edge infrared detection technology, the JWST is like a superhuman eye that can see objects and phenomena that are invisible to our own eyes. The result? Astronomers have captured jaw-dropping images of galaxies and clusters, including the distant and elusive MAX 0647JD, sending shockwaves through the scientific community. The image reveals a stunning sight, a breathtaking group of galaxies that twinkle like precious gems against the vast emptiness of space. But what has scientists truly excited about this image isn't just its beauty, but the wealth of information it provides. MAX 0647. JD, a distant galaxy first discovered a decade ago by the Hubble Space Telescope, has been studied in much greater detail thanks to the JWST's triple lens effect, allowing for new insights into its structure, composition, and behavior. Scientists are particularly fascinated by the question of whether MAX 0647JD is a single galaxy or two clumps of stars within a galaxy, and they're hopeful that the JWST will finally be able to provide an answer. But the JWST's discoveries don't stop there. The telescope has gone further, revealing galaxies beyond our wildest imaginings. And not just any galaxies, but some of the oldest in existence, like Z12, captured just 350 million years after the Big Bang. Let that sink in for a moment. That's a galaxy over 13 billion years old, and its discovery has shaken our previous understanding of the origins of the universe. Previously, the furthest we could see back in time was the galaxy GN-Z11, which existed just 400 million years after the Big Bang, as observed by the Hubble Space Telescope in 2016. But with the incredible capabilities of the James Webb Space Telescope, we have been able to look even further back in time, revealing galaxies that existed just 250 million years after the Big Bang. The candidate galaxy Sears 93316, with its staggering redshift of Z equals 16.7, is a testament to the unparalleled technological advances of JWST. This galaxy is so far away that we are seeing it in its infancy, and its discovery is part of the Cosmic Evolution Early Release Science Survey, which is using the JWST to take images of distant galaxies while spectroscopy is still underway to confirm the redshift. Initial data from NIRCam have already ruled out the possibility that it is a low-mass star or an unobstructed active galactic nucleus. The discovery of SEERS 93316 adds to the growing body of evidence suggesting that galaxies formed even earlier than previously thought. What's so exciting about this breakthrough is that it takes us back to a time before any of the stars we know today even existed. It's like finding a hidden treasure that leads us to what is commonly known as the Dark Ages, a time when the universe's first galaxies were thought to be forming. It's a bit like peering into a time capsule that takes us back billions of years and gives us a rare glimpse of what our universe was like in its earliest days. The discovery of SEERS 93316 is just the beginning of what's possible. NASA has indicated that JWST will be able to detect galaxies at redshifts greater than 20 million years after the Big Bang. This means that the discovery of AEL 2744Y1 is so far away from us that it took an incredible 13 billion years for its light to reach us, making it almost as old as the universe itself. But despite the distance, the Spitzer, Chandra, and Hubble telescopes have captured an image of this remarkable galaxy. Working together to collect data at different wavelengths of light, they even used gravitational lensing, a phenomenon predicted by Albert Einstein, to capture an image of AEL 2744Y1. What's truly amazing about this galaxy is not just its age and distance, but its rate of star production. Despite being only 50 times smaller than our own Milky Way galaxy, AEL 2744Y1 is producing stars at a rate 10 times faster than the Milky Way, which is typical of galaxies in the early universe. This incredible rate of star production has left scientists in awe and curious about what else this galaxy has in store. Although studying this galaxy is no small feat, the information gathered so far is sure to keep scientists busy for many years to come. Have you ever stopped to think about how big the universe really is? It's so big that it's hard for our brains to comprehend. But despite this mind-boggling size, scientists have been trying to measure it, and what they've found is truly inspiring. The observable universe alone has a radius of 46.1 billion light-years, but there's so much more out there that we can't even see. Based on observations and our knowledge of physics, scientists have determined that the universe is flat on the largest scale, with a remarkable accuracy of 0.25%. But if the universe is curved and loops back on itself, the observable part could be at least 23 trillion light-years in diameter, containing over 15 million times the volume we can see. Some scientists even argue that the observable universe could be much larger than this, as it's possible that the hot Big Bang only marked the beginning of the observable universe, and not the birth of space and time itself. But that's not all. There's still so much we don't know. Before the Big Bang, the universe went through a period of cosmic inflation, during which it expanded exponentially, creating new space at an incredible rate. This raises many unanswered questions about the size and nature of our universe. For example, what was the size of the region of the universe that experienced inflation? Is the idea of perpetual inflation correct, where some regions of the universe continue to inflate indefinitely into the future? And how long did the inflation last before the hot Big Bang? It's possible that the universe in which inflation took place was barely larger than what we can observe, or that evidence for an inflationary boundary will emerge in the future. Despite all these uncertainties, there is the exciting possibility that there are countless other universes out there, just like ours, with similar physical laws and structures. This raises the tantalizing possibility that complex life could exist in one of these many worlds. The vastness of the universe is truly mind-boggling, but the possibilities are equally incredible. What's more, it is believed that there should be a finite size and scale to the bubble that marked the end of inflation, with an enormous number of such bubbles existing within the larger inflating space-time. The sheer vastness of the universe is simply breathtaking, and the possibilities are endless. It's mind-boggling to think that we're just a tiny speck in the grand scheme of things, with so much yet to be discovered. For example, the most distant galaxy ever observed by humans is GN-Z11, which is a staggering 32 billion light-years from our planet. This means that the light we see from GN-Z11 today began its journey towards us when the universe was just 3% of its current age. The distance to GN-Z11 is so vast that it's hard to imagine. When you take into account the expansion of space, the distance from Earth to GN-Z11 is a staggering 46 billion light-years, almost half the age of the universe itself. What makes GN-Z11 even more fascinating is that it marks the limit of what we can observe. It's at the surface of the last scattering, where the first photons of the cosmic microwave background radiation were produced after recombination and photon decoupling. In a sense, GN-Z11 represents the edge of the observable universe, beyond which we can't see or observe anything. Looking out into the vastness of space, it's easy to feel small and insignificant. The universe is so vast and infinite that it can be overwhelming. But as we delve deeper into the cosmos, we gain a better understanding of our place in it. By exploring the origins and evolution of the universe, we can learn about the processes that have shaped it over billions of years. Trying to fathom the size of the universe is a humbling exercise, reminding us how small we really are in comparison. At the same time, contemplating the infinite possibilities that lie beyond our limited perception of the universe is an awe-inspiring experience. The James Webb Space Telescope has opened a window into the unknown, revealing aspects of the universe that were previously beyond our reach. With each discovery, we inch closer to understanding the true nature of the cosmos. But at the same time, we are reminded of just how much remains a mystery. The discoveries made so far have sparked more questions than answers, leaving scientists both excited and humbled by the sheer scale of what's out there. From the distant galaxies like Mach 0647JD to the possibility of finding new universes, the JWST has set the stage for a new era in astrophysical exploration. As we continue to analyze these groundbreaking findings, one thing becomes clear. We are on the cusp of uncovering truths that will redefine our understanding of space, time, and the very fabric of reality itself. So, as we stand on the edge of this new frontier, it's essential to ask ourselves, what do these discoveries mean for the future of humanity? Will we ever fully comprehend the vastness of the universe, or are we destined to remain small players in a cosmic drama that's too grand for us to grasp? Only time will tell. But one thing is certain, the James Webb Space Telescope has opened the door to a new age of discovery, and we are only beginning to scratch the surface. As we continue to push the boundaries of what is possible, the only certainty is that the universe will continue to surprise us, challenge us, and inspire us to look beyond the stars. With each new revelation, we are reminded of the incredible potential for exploration and discovery that lies ahead. The mysteries of the universe are waiting to be uncovered, and with tools like the JWST, humanity is poised to answer some of the most profound questions ever asked. So, what will the next great discovery be? Only the cosmos knows, but we are now closer than ever to finding out. So, what are your thoughts on these groundbreaking revelations unveiled by the James Webb Space Telescope? Please feel free to share your thoughts in the comments.